Hello developers, let's start developing. My name is Veko and today we're taking on the 19th day of the 2024 Advent of Code. First of all, I think I might have solved my video quality issues so they won't look like they were taken with a potato camera, but we'll see when we upload it actually on YouTube. Anyway, we need to do some towel management. Actually, I've been more than once in a discussion about how to best organize socks when you take them out of the washer, but this is something totally different. We have some towels that have stripes. We have 5 different options of a stripe: white and black, red, green, and blue. So, we have a set of patterns that are available. So these are the patterns that are available. We can have a red stripe, or we can have a white stripe and a red stripe. So if we want to implement something, we can generate any design that uses those patterns. So we have these patterns and we need to implement these designs. For example, you can have this design have blue, then a red, then a white red, and then another red, and that will work. But this design, I think, since it starts with a U, it's just not possible to do. There's just no pattern that starts with a U. And they told us that we cannot flip the designs because that will mess up the logo. Of course, that's the important part. So now we need to find which of these designs are possible and which are not. As we usually do, let's start with parsing the input. Of course, our input is going to have some specific type. Let's just call it input, since it will have a list of patterns, which is a string array. Is it going to be a string array? It's going to be something a bit different, but let's go with string array right now, and it will have a designs, which will be an array of a bit bigger strings. So let's actually parse them. So we're gonna take the first line, that's the pattern line, are the first line, lines of 0, and we're gonna split it on a, actually this is separated by a comma space. So we're gonna split it on comma space. Let's just check for a second that the actual input is also separated on a comma space. Yes, it is. That's the correct thing that we need to do, to separate it. And that's all that we need. So lines dot slice off the first two, and those are the designs. And we're going to return the patterns and the designs, which means that we are returning, instead of a string array, our input. But this will make a boo-boo, since search replace kind of doesn't really think about things, and neither should it. So we have our parts. So let's just, as always, console log the input. Let's see if we mapped it correctly. A lot of the times people will solve everything correctly, just have an incorrect input, and that is a problem. So we have 8 designs, starting with BRWRR, ending with BBRG, and so on. And we have 3328 patterns. Yeah, seems like we don't have extra spaces anywhere, since we have all the patterns and all the designs, and that's great. Since the patterns and the designs are not really connected, we can destructure them here. So now we're gonna say how many of them are possible. That's gonna be 0, and we're just gonna loop through all of the designs And if is possible, that design with those patterns, then we're basically just gonna increase possible and return the possible value, and we're done. Except the small thing when we should actually see whether something is possible. So what we can do, this function is gonna be, I'm gonna implement this function in a recursive way because that's kinda easy. So for example, for this br or whatever we can have which patterns are contained in this design. So if the design starts with the pattern, it starts with this one, it starts with this one, it's quite possible that after that we will need to basically call this twice. So now we will have two different questions: whether this design is possible using those patterns, and also whether this design is possible using those patterns. So which means that we're not running through the design, we're just gonna say patterns filter only those patterns where for that path specific pattern the design starts with that pattern. And these patterns are actually applicable to that design. So for each pattern of the applicables, we're just gonna need to ask, is it possible to implement that design using the implement the rest of this pattern using all the patterns, because we are in no way constrained. We can, if we have a BBBBB design, we can only implement it with B's straight all the way and nobody cares. So if it's possible, we can just stop processing and return true. Otherwise, we're going to return false. So if nothing is applicable, it's done. Now, this is very interesting design, very interesting implementation as well, as we have basically not a lot of code. We're just saying, remove this, check it, remove this, check it, remove this, check it. Eventually, we will get to an empty design. Will we? I have no idea. If we slice everything off, we will have an empty design, and an empty design is basically true. It means we got there. Yeah, that is actually, we would have missed our, everything would have been false. We would have missed our exit criteria because each recursive function needs to have an exit criteria. The problem here is that there will be quite a big fan out, which means that for a single design we can have 15 patterns that are that are applicable, which means that from one call to is possible we will generate 15 calls, and each of those 15 calls can also generate 15 calls, and so on and so forth. And if we have a significant amount of depth, we might get to a ridiculously huge number. For example, if we have a depth of 10 and a fan out factor of 10, we will basically go 10 to the power of 10, which is something like 10 billion calls, just for a single check whether something is possible. But this is a relatively small input, so let's see. It says 6. The value that we were supposed to get is 6, but I'm not quite sure with recursion that I'm doing it correctly. Maybe we got lucky, so I will just say console log is possible, else design is not possible. Let's see if we actually do that correctly. It says everything is possible except two of those, and two of those are UBVU, and the last one BBRGB. Seems okay. Seems that we are doing right. So next thing that we need to do, take the huge input, and you can see that with recursion we have to be always mindful of the size of the input, because the same code for a different input can be dramatically different. Actually, I will leave this in. There are around 400 designs and they're quite independent, so we will see whether this runs immediately or runs until the end of time. So the first one is possible, and we are getting lag now. Well, let's take a break and see if this thing eventually finishes. So it's some minutes later and this thing still haven't budged. I will kill it. It ran for 13 minutes. I took a small break and we still don't have a result for our second part. Well, there are quite a few possibilities, so I will start eliminating them one by one. So the first one is that we actually did something wrong when we read the input. Console.log input. We'll guess that I want to. No, we didn't. Yeah, we want to display the patterns and the designs first. Let's see, the second one looks quite okay. So it still broke over there. So the second option is that we have some kind of an error in our code, and the third one is that this input is intentionally designed to basically mess up with recursion. So one of the things that I will do, which will kind of slow down this thing, is inside is possible, I'm gonna say that we're checking the design. The most likely option is that we made an error in the code. So we're gonna check only that design. And it's not that it's not checking it, but one obvious thing is that, yeah, this is intentionally designed so that it triggers catastrophic backtracking. So we're checking all the time. But why are we doing that? We're checking the design R. It ends with an R. Is there R? How many things that start with R? We don't have actually that. Do we have something like R comma space R comma? No, we don't have an R. So that always fails. Most likely this is not a possible design. Let's see if that is a possible design. Oh, this is gonna go off the rails immediately. Yeah, that is not a possible design. So it ends on something that is not possible. So I kind of wanted to do this later, but on the other hand, it might make sense to actually have it a bit sooner. I will call this EMPL. So, it's possible will actually be like that, and it will return another function. Or, yeah, we will take care of that a bit later because it will be a better design. For now, we're gonna have a global cache. and I will have that as a map of string and a boolean. So each time when we determine whether a pattern is possible or not, we're just gonna save it. So now we can say here, if that cache has design, return the value for that design. So if we check that R is not possible once, we don't have to check it again. Otherwise, so now, whenever instead of returning, we're just gonna set that also to the cache and on each return. We actually don't need this because all the designs of length 0 are totally the same. We can just say cache.set that is true. Later on, I would like to wrap this whole thing inside one function. Actually, we can do that immediately. Not alt, but actual is possible, and this is inner. This is very easy in JavaScript because now we just need to return this thing. So whenever we're calling is possible, no, we don't want it that way. We don't want to return that because then we will create our cache all the time. So I will actually wrap this thing like this. So when we call is possible, we're gonna create a function. So we're actually up to here, and once more we need a comma here, and this actually closes this thing. Let's put some parentheses so it's not okay, so it's not a problem. And this parenthesis needs to be a bit before that. So now is possible is actually looks just like the same thing, only it doesn't return that. Why doesn't it return anything? Because this is a function that returns actual things. Oh, we will need to write it like this. So now this is a function that will return a boolean or an undefined. How do we return an undefined? If we say that, yeah, we know that this thing has that, it will actually return a boolean. Yeah, let's run it for the small input first. We know that it was supposed to work for this thing, so let's make sure that it still runs for that. Design is possible, the design is possible, that design is not possible, and we have that. So let's run it for the bigger input. I will copy it over from the site once more so that I don't make any copy-paste errors. So let's see what happens now. A lot of things are happening, and I will remove the console log because it is kinda messing us up. So now this runs much faster. What is the issue? The issue is that we have this thing on this part, I would say, on the second input that actually triggered a catastrophic fan out. So we have 10 times to the 10th, so we went to those billions and trillions of combinations that are supposed to do. It's possible to actually calculate how many there are, but it's gonna be too much. And know that most of the time we're gonna do the same thing. For example, if we can do this in two different ways, which means that both different ways will leave just this part. In both of those branches, we would need to calculate whether this part actually is possible or not, because we know that this is possible. And if this is possible in 20 different ways, then in 20 different times we would recalculate this. What I did, I said, if you calculate it once, you don't need to calculate it again. So now we got this thing a bit faster, and it says 338 options are valid or possible. Let's see if that is the correct number. It is. We got a star. And now I am quite afraid of the second part, because I have a feeling that it also will include recursion, but in a trickier way. To avoid an endless, you should just give them every possible options. So this can be made in two different ways, that or that. That can be made in that way. That can be made 4 different ways, 6 different ways, 1 different way, 2 different ways, and those things are still impossible. So now we're gonna need to return something else. So this is gonna be is possible 1. And for the second part, this part will be totally identical. Once we make it actually identical. Only we will be calling not this, but we will have some other code that says const combinations is possible to, we're not gonna call it is possible, so I will rename this to is possible, and we will have another method that says count combinations for that design and those patterns, and then on the total we're just gonna add the number of combinations. Of course, we're gonna return the total. And now we will just call this as count combinations. Of course, this will be the inner version. Instead of doing that, instead of having a cache that is a boolean, it will be a number, and that has exactly 0 ways that we can do it. And we will need here, instead of just checking, here we had a nice thing that the first time that we determined that the design is possible, we can just stop. Now we will need to say how much times we can do that. So once more, if we see that this part can be done in 10 ways, then, and we know that this time the thing can be done in 20 ways, we will need to actually multiply them, because they're totally independent. So we're gonna get a huge number, but that will have to wait for part 2. So click on those buttons below, like, share, subscribe, comment, don't click on the bad button, and keep developing.